Hello, everybody. I know the last session just ended, so gonna give people a chance to come on over and join us here. And I've got to say, I'm excited about this talk. The topic of security in the industry is a huge one, and with the amount of attention being paid to moving workflows into the cloud and changing the way that kind of where data is accessed, how data is accessed, the high walls approach to security that's just not getting less and less realistic as the days go on and COVID's here. This is a very apropos topic. So let's see. Yeah, there's a bunch of you already in here. So I'd like to introduce our next speaker. Spencer, if you come up here on the virtual stage with me. So Spencer Stevens is Senior Vice President of Production Technology and Security at MovieLabs, where he leads MovieLabs' work on the security of production workflows. He was principal author of the MovieLab Securing the 2030 Vision Whitepaper and the Common Security Architecture for Production. Before MovieLabs, Spencer ran TechX Media, a consultancy engaged in cybersecurity, production technology, and cloud workflows, and served as CTO at Sony Pictures Entertainment. So without further ado, Spencer, over to you.
Thank you for the introduction, Rob, and thank you for inviting me. Let me just share the screen. That was always an exciting moment when you're using Zoom. Okay, hopefully that worked. All right, so what I want to talk to you about today is the common security architecture for production. And I think the important thing about this, important place to start here is this is a workflow-driven security, which is a very different approach. But before we get into that, let's talk a little bit about MovieLabs. MovieLabs is a technology joint venture owned by the 5 major studios. And our mission there is to really drive innovation and deliver tangible solutions. So, you know, we focused a lot in the early part of MovieLabs history on distribution, security, did a lot of work on high dynamic range in 4K. And now we've turned our attention much more to production. We produced a series of white papers over the last couple of years. And the core one is the evolution of media creation, which is our vision of where production is going to go. And, you know, spoiler, is going to be production in the cloud. And we followed up with the evolution of production security, which is our conclusion when we did the original vision paper was the fact that today's conventional ways of doing security of production just won't work very well. You know, they get very complicated. And then we've also got other thread here, which is on actually the production workflows themselves. Basic vision benefits, I'm sure you all understand that, is the benefits of cloud native, all that sort of thing, you know, rapid studio in a box trial, the model, the new security model coupled with a second thread, which is a production user ID. And then really the notion of automation, which is in our software-defined workflows work. Our cloud foundation projects are about assessing the industry readiness for security, which is an interesting, sorry, for a cloud production, very interesting exercise to go through, and then identifying areas of improvement and so on. But a lot of this is around the notion of a software-defined workflow, and we have a lot of work going on about ontology at the moment, a broad-reaching ontology, which allows us to control it. And also, by the way, one other thing here in the bottom right-hand corner of this slide, you'll see that we've actually defined a visual language for describing a workflow, so that when somebody puts up a diagram that shows the workflow, you don't have to figure out exactly what each component of it is. But let's go ahead to the real meat of this, which is our security architecture. It's definitely workflow driven, and it uses dynamic policies. And this is really important because it was designed by people that knew a lot about production and about security, rather than people that knew about one or the other. And it's really built very much on the principle that security must not get in the way of the creative process. And as all my work in the entertainment industry, I know that in the end that your A-list director will call the chairman and say, please turn off the two-factor authentication because it's driving me nuts. And the two-factor authentication will be turned off, which is not a good security proposition. Key features of it, one is that it is definitely security by design, which means we need to build it in now before we get too far down the road of deploying applications and work into the cloud. The other thing is very much a zero trust architecture. And when we first did the white paper, that wasn't as mainstream as it is now. But earlier this year, the president of the US directed all of the federal agencies to adopt zero trust security. So probably the best endorsement we've got of that. It's definitely meant to be scalable. And in production, not everybody needs the same level of security. And however easy the security is, the more you've got tends to cost more. If you're doing a reality TV show, you've got a different level of risk tolerance than if you're doing a major effects-heavy motion picture. And I think what we're also seeing here that's really important, and this is kind of actually wasn't one of our design goals, but it's turning out to be one of the most important things about it, is the fact that having a common interoperable security architecture makes stuff so much easier because you're not trying to take from one workflow environment to another that just has a very different approach to security. This is designed to be multi-cloud, and by cloud there I mean both public and private cloud. So let's look at the reason why we did it. Today's production infrastructure, primary data center, more people are now using a hybrid cloud where the cloud portion is augmenting what they've got in their data center. But the fundamental point about this is that they're able, one way or another, to put a security perimeter around everything. And the applications are running on the local infrastructure, and the data is moved to the application. In our vision of the future of production, media production, we're talking about production in the cloud. At this point, the cloud becomes a global production resource that's used by everybody working on the production. And that includes not only the post house, the big VFX houses, the studio, but also all of those individual contributors that are working directly off the cloud. And this was definitely sort of a vision when we started, and now it's reality. So this part of the vision has really accelerated tremendously. But the most important thing to look at from the security point of view here is that everything is happening outside of the security perimeters that each facility has built. You could probably extend that security perimeter to encompass all those individual contributors, but it would be really difficult. So I would say not possible. Let's look at it another way. What happens today with a perimeter security is that the components of a workflow, which is the participant, the person doing the work, as a simplistic definition of a participant, what they're doing, what they're using, the device and application, and the asset they're doing are all protected by a security perimeter. So they're running on a trusted infrastructure, or at least it can be trusted to the extent that you can trust your perimeter. But the security is imposed from outside of the workflow, and it definitely only works if you can trust the infrastructure. We decided a very different approach was needed, and the common security architecture for production is very much workflow driven, and the security is part of the workflow. So here we have an authenticated participant. Part of zero trust is we don't let anybody join the workflow unless we know who they are, unless we're sure we know who they are. Tasks have to be authorized, so cannot do arbitrary things with the data. It's possible to do it for a permitted amount of time, and the permitted time might be a time period, or it might be between two events, or some combination of that. The device must be trusted. In other words, you must know that you can trust the device, and the application must be approved. And we'll come back to what you can do with the application in a moment. And then the asset is protected. And if you're turning the dial up to 10 on this, then you're encrypting individual assets, which has a lot of advantages over encryption at rest, because encryption at rest is protecting the container that the asset's in, and only therefore indirectly the assets themselves. But you see the big point is that this security is part of the workflow. The CSAP architecture looks like this at a very high level. We divide it up into these boxes. The core security components are in the middle there, and it is consists of 4 services. One is responsible for authentication. One is responsible for authorization. And we split the two up. If you have a traditional identity and access management system, then they're actually conflated. But in our case, at least architecturally, we look at those as being 2 different things. Then we have whatever's protecting the asset. And as I said, that could be individual asset encryption, in which case it'll be doing key management, or it could be access management, or it could be directly controlling access control lists. And then the policy service server there, which is really got 2 components. One is the policy manager, which takes the dynamic policies that the authorization server creates at the behest of the workflow management system, and it combines it with any sort of global enterprise level policies, and also with threat and intelligence that's coming out of the supporting security components. And we've tried to minimize the number of things that happen within the core security components, because those are the ones that become specific to production. As much as possible, the architecture is in the supporting security components, which are security functions that can come from cloud provider services. And if you looked at the security on AWS or Azure or Google Cloud, you'll notice that they've got a lot of things available. And we have been through mapping exercises to make sure that all of that stuff is in there. So we've tried to use and been successful, I think, in moving everything out into there. And one other point here is that those 6 boxes inside the supporting security components are really functions that we expect the whole box to provide. They're not anything at all to do with how it might be divided up amongst the cloud provider security services. And then the 3rd box on the left-hand side of the screen here is really the workflow management. And whilst not strictly speaking, it's not part of the security architecture from the point of view, it's not providing security, but it is providing the direction that that controls the security system. So when a task is created and the workflow management system say this is going to happen, then it informs the security components. So that's the case. And at the same time, whatever asset management system in there which knows what assets need to be accessed is also informing the core security components. And the last bit of this is down at the bottom here, and this is focused on the policy enforcement points. And these are the point where the security architecture actually acts on the components of the workflow. In other words, that's really where the action happens, and they're controlled by the policy engine and the core security components, which is the main real-time aspect to this. Let's look at the dynamic security policies, because they're a very important part of this. Basically, there are 3 rules within CSAP. First of all, is that nothing can join any workflow unless it's been authenticated, and that means both its identity has been checked, but also that entity can be part of the workflow. But then it can't join a specific workflow or a specific part of a workflow, depending on how you define that, unless it's been authorized to do that. So there's 2 factors here, not 2-factor authentication, but there's 2 factors here, both authentication and authorization. And then the third thing is that the authorization to be part of that workflow is for the minimum period to complete the task. Now, that doesn't mean necessarily expires in 24 hours, because if you have an editor working on a production, then clearly the minimum period for them is the point from when they're hired to when they leave the production. But other people that are working, for example, on a particular scene, then the authorization there does not, to access those assets, does not need to extend beyond the period where they're actually working with those assets. So what we have here is not just least privilege, which is one of the basic rules of security, but we also have a temporal aspect to that. So let's go through how the authorization service works. It starts out with the workflow management sending a request to the authorization service to authorize an activity. The authorization service itself is not making any decisions. It is responding to those requests from the workflow management. And the authentication service there is going to ensure that whatever the workflow management system is saying is part of the workflow has been authenticated. And those go into the authorization service, and they're put together with a policy template. And a policy template is really a way of saying, well, how do I translate those requests to authorize an activity into the dynamic policies, which is what the authorization service creates. Now, if you're using identity and access management system and you want to use the access management component of that, then those IAM permissions also are factored in and become part of the dynamic policy. And then dynamic policy, when it's being constructed, is sent out to the policy service. Another way of looking at this is to look at it on a timeline. And it starts out again with the workflow management system initiating a task in the top left-hand corner there. It assigns resources and participant, again, think of that as a user. The core security components will then authenticate each part of it or make sure they're authenticated previously. And at this point, the supporting security components are doing identity management, but also trust inference. We're drawing a lot on the notion that the trust inference says, well, if you log on to the system exactly at the same time every day, or just an example here, from the same place, and it's the same system, and you pull up the same applications, I can trust you. I can inherently trust you a lot more than if you suddenly appear to log in from the other side of the planet using a system we've never seen before. So trust inference is modifying the level of authentication that's necessary between, okay, I can trust you, to, well, I don't even trust you even if you have the right credentials. The next step of this is that the authorization policy is created. And remember, that is a direct response to what the workflow management wanted to have done. The asset management system will locate the assets. And in the case where we're doing individual asset encryption, then the asset protection service will generate those asset keys and prepare them for delivery. And then the dynamic policy is sent to the policy manager, and the policy manager does make decisions, and the decisions it makes is to combine the policy, dynamic policy that comes from the authorization service with global policies that the enterprise, think of that as studio versus the production, may have imposed, and also what the latest threat status is. So, for example, if work was scheduled to go to a particular vendor, but the threat intelligence said, well, wait a minute, that vendor has been completely compromised, then at that point you would say, well, wait a minute, this dynamic policy isn't permitted, and there would be a feedback loop there. Then this goes out to the policy engine, signals what the policy is to the policy enforcement points, which do all the work, keys are delivered, and then the magic happens when the task starts. Let's look at the policy enforcement points, because they're a very important part of this. The policy enforcement point sits at the point where the work actually happens. So trusted device, the policy enforcement point would be part of that. I won't talk at the moment about how it's built into it, but it might be endpoint security, and it will only allow the participant to connect during the permitted time period according to the dynamic policy that's been delivered to it. And then the approved application, the policy enforcement point will only allow an approved application to run. And there are various ways that you might approve an application. One is because you want to ensure it's secure. The most simplest form there is a signature, but there may be other things you want to do in similar to the trust inference. But also the fact that you can, and this is a fundamental difference between this workflow and standard InfoSec security, is that this security is capable of maintaining the integrity of the workflow. So if you decide, well, wait a minute, only this version of Maya can be used, then that can be enforced at this point in the security. So the security is not just protecting the assets or the workflow from denial of service. It is also protecting the fact that the workflow, or can protect the fact that the workflow happens the way it's supposed to. Let me just make a point here, though. This is a highly scalable security. So when I say you can protect the integrity of the workflow, what I should add to that is if you want to. You may not need that. You may just simply trust everybody to use the right version of an application. And then the last thing is there's a policy enforcement point where the assets are actually accessed, and that is making sure that the who, what, where, and using applies to those particular assets. And if you've got, there we go. If you're using a service rather than a device and an application, much the same thing sort of happens. In this diagram, simplistically, you would just simply replace the trusted device and the approved application with a trusted service. What that means for SaaS providers, and remember, we expect a SaaS provider to maintain the fact that they are a closed environment. Typically, that's the case. So, but this does impose some requirements on them. The most important thing it imposes is this need to set both authentication and authorization according to the dynamic policies from outside of the SaaS. So this is more than simply integrating the SaaS service with Active Directory or some sort of SSO, and then configuring permissions through a console. These have to be configurable through an API of some sort. The next thing is that depending on where you have the dial set on security, if you've got it up pretty high and you're using encrypted assets, then the SaaS service is going to have to figure out how to deal with those assets. So if you decrypt them on the way in, it's one approach, but then you're trusting the SaaS service to be secure, and that's a risk tolerance decision. It's not a technical decision. And then the last thing is that in these exposed interfaces, and these are going to be necessary anyway, but to emphasize the point that the SaaS service must report when tasks start and when they finish, so that the dynamic policies can act appropriately. And let me say, they don't need to report that to the security system directly. Presumably, they're going to be reporting that to the workflow management anyway. But if you're going to use dynamic policies that are permitted for a certain period of time, then that's necessary. Securing applications themselves does present some interesting challenges. The first one is that you are encrypting assets individually. Then you've got to figure out how to do the key management, the asset decryption and encryption, and the file caching. The good news here is that the AES cores, AES components of Intel CPUs are extremely fast. And we're at the moment testing some of that stuff, but I don't think we have to worry too much about the speed it takes to decrypt or encrypt assets, because that is done in a hardware engine within the CPU. It's no longer a question of I need to do that using software, or at least not if you use the right libraries. But the other thing about this also is that the application must be authenticated, and its integrity checked both before and during runtime. And if you've got any knowledge of how content security works in distribution, you'll start seeing here that we've actually a lot of parallels between this and the actual content protection layer of a DRM, not the rights management layer, but the actual content protection layer of it. And the way we address this, there's already two approaches to address this, because it would be unreasonable for us to expect the security to build into the application, and there are lots of reasons why actually you don't really want to do that. In the same way that if you take a player for a streaming service, the security is a module within it. The player itself is not necessarily secure, or it's not for the reason of protection of the content. So the two ways of doing this that we've been exploring, one is that there is a security wrapper around the application. So the application is sealed inside this wrapper. It doesn't know it's there. And that wrapper is doing both authentication of the application itself, including one of the solutions we've been looking at characterizes the application beforehand. And then if there is a significant deviation from that, then it will, it will start signaling, flagging that as happening. And then in that case, the application and the operating system don't really need to know about the security because it is happening in this wrapper. And in this case, the entire operating system, data storage and stuff is no longer necessarily part of the trusted infrastructure. The other way of doing this is a shim, which you would normally put within the operating system or within the drivers. And that shim might be, between the application and its data storage, so that the shim is what's doing the encryption and decryption. This means that there's a little bit more trust on the operating system, and we're exploring both versions of this. As I get to the end of this, let's talk about where we are now. We published our security white paper at the end of 2019. We followed it up a year later in January of this year with the main parts of the architecture. Part one is where the meat is. It's the architecture description. Part two is a high-level view of the sort of interfaces that are necessary to implement the architecture, but is not anywhere near at the level of detail you'd need to actually do it. It's a precursor to implementation. And then part three is security levels. And we're not here talking about any sort of assessment process, but what we're saying is there's a lot of things you can do with this architecture, and we'll take three levels, 100, 200, 300, and here are the components that we think are needed to produce those three different levels of security. Again, level 100 would be for a production that had a reasonably high risk tolerance. Level 300 will be for a production that had close to zero risk tolerance. We're in process now of creating three more parts and best practices for it. Part 4 will be specific on securing software-defined workflows. So it will talk about in more detail about how the security architecture will interact with whatever's controlling the workflow based upon our view of what a software-defined workflow is. Part 5 is some implementation notes, and we're doing that in parallel with the cloud providers producing their own guidelines to implementing the architecture on their cloud services. The policy description language is in some ways the bit that we have to cut out whole cloth. And the policy description language is how you convey what the workflow management system wants to see happen, and then how that is conveyed from the core security components out to the policy enforcement point. So there's a formal language for describing that. It sounds easy, but actually it turns out we couldn't find any references to anybody having done anything like that before. And then we're also producing something called enhanced content protection for production. It might seem like a weird name, but MovieLabs produced something called the enhanced content protection for distribution at the point of the inflection point of going to 4K. And it radically shifted the level of security on the distribution of content to consumers. There we used the green field of 4K to introduce a new security architecture. Here we're doing much the same because there is a green field on production in the cloud. There's not really much going on that's in any sort of a unified fashion as yet. And so we find this as being the best time to come along with our security architecture. We are also starting to work on we have a sandbox, which is mimicking or modeling production in the studio. And we also have several other proof of concepts underway. So that really is it. There's the MovieLabs website, a link to go directly to the download of both the CSAP architecture, the first 3 parts, and the white paper. And there are my contact information, my email, and thank you for your attention.
Excellent. Thank you, Spencer. That's fascinating. We're going to switch over. We've got about 8 minutes for Q&A. Going to start just asking a question that I have, and then Tram is going to join us and feed in some questions from the Whova Q&A panel. But feel free to stay on camera, Spencer. So, my question is just, Nick, as an industry, it seems pretty obvious. We have some growing up to do in how we think about security. The high walls model from forever ago is just not going to hold up as we move into the future. And you talked about some significant challenges, like that transition is a huge lift. What kind of response have you gotten from like the studios, the device vendors, the cloud vendors, the application vendors? Like, we're a heterogeneous environment. There's a lot of different vendors to adopting this kind of a security model.
Yeah, so I think the first thing to realize is that anything MovieLabs published is endorsed by the studios. We don't publish anything unless all 5 studios are happy with it. So, you know, in terms of studio support for it, that's inherent in the fact that MovieLabs published it. If you look at the cloud vendors, they all agreed, and we've seen presentations in private, that you can build this security architecture using their components. And again, certain amount of tweaking for some things and far less, tweaking for others. So the authorization service, they've got the components to build that, but you'd have to configure it specifically for this application. So, and if you look at, not wishing to single out any particular cloud vendor, but this architecture, if you read the white paper, is very closely aligned with Google's BeyondCorp, which is the way that they've been protecting their enterprise network and resources for a long time. It's a zero trust architecture they've been using. And, it's one of the things we cite as an example in the white paper. So, it goes without saying possibly that as they start bringing BeyondCorp and BeyondProd to market, we're in close alignment with that. But the other security vendors have also got plenty of tools for building zero trust. And so, I don't believe, other than just a couple of things, there isn't any real significant hurdles here. And we did try and design it and hopefully succeeded in not having any boxes in it that says magic happens here. Mm-hmm. We're also seeing an interesting response, because as we talk to effects vendors and post houses, it's like, in some ways they sort of welcome this, both because it will help them protect their distributed workforce, but also because the notion of having a common security architecture between them and their clients, and remember, any production is not just simply using a single VFX vendor. Actually, my rule is that you can tell how far a production is behind schedule by the number of VFX vendors in the credits. that common security architecture, the common security model, even if it wasn't this one, that's valuable by itself. And then, surprising amount of interest from, application vendors, because they understand that if they're contributing to security, it's a good thing for them.
Yeah, that's excellent. All right, I think we have time for a few questions from the audience. So Tram, what is our first question?
I'm going to combine two questions together because they're very similar and related. What do you think about all of the new viruses appearing in DCC tools like Maya? Now that users are working on remote machines, it seems like they're showing up more often than before. And the second that's related is, how can we prevent and clean infected Maya files? For example, any code embedded as a nuke script, or sorry, a script node and triggered when someone opens a Maya file.
So I think that the second question is actually intrinsic in the response to the first question. And the notion here is, you've seen here, we have the notion of a trusted application. And the trusted application is done, if you really want to turn the dial up 10, that can be done by both signature and also runtime analysis of the application itself. And if the application goes and does something that it hasn't done in the past, and that's typically what happens when some malware gets in an application, then the system will prevent that from happening. The other thing is that if you're only feeding the application assets that it actually needs to use at that moment, rather than turning it loose on a folder that's got a bunch of unprotected assets in it, then you may not necessarily prevent the malware getting into the application, but you can stop it propagating through the files in that folder, because it's only able to access the ones that that user needs at that moment in time to do their work. So you're doing it on two separate levels. The infected files, I won't go into how you clean them out, because actually that's more of a remediation thing. But if you get an application, Maya loads up and it loads infected files, then the first part of this, which is you trusting the application, and if it doesn't behave in the way you did when you trusted it, it will stop, or it will be stopped. That was how you prevent the propagation of this. But the interesting point here, I just want to emphasize something I just said. The goal of perimeter security is to stop any breaches, and it is largely unsuccessful in that. And traditional perimeter security spends a lot of time trying to find intruders in your network. Well, if you think you're going to get intruders in your network, why are you putting so much effort in trying to stop them getting in the first place? Why don't you stop them being able to harm anything in the network? That's really it. We're assuming that the network has been compromised. You're assuming that your applications may have been compromised, which is why you're using zero trust. You're not letting an application be part of the workflow unless it's been authenticated. And in the case of an application, that means, is it behaving the way it's supposed to?
Great. So the next question. For studios without thin remote clients, what ideas might they have to secure data on the artist machines?
So if you look right back at the beginning of this, when I first showed the sort of basic, the 6 boxes of components of the workflow, trusted, authenticated participant, authorized task, all that sort of thing. I showed that running on an untrusted infrastructure, because when you're using zero trust, one of the things you're doing there is that you are collapsing the attack surfaces down to the absolute minimum possible. One might argue it is still got a perimeter, but the perimeter is minute. It's as small as it could possibly be. So if you're using zero trust, then and you're running on a machine you don't trust, then, for example, in the last thing I showed about the application, then you put a trusted security wrapper around the application, and then you don't need to trust the machine it's running on. we think that the whole approach of zero trust in this manner, and we're not the only ones that think this way, that's far easier to do than trying to secure somebody's home network. My glib comment there is that anybody that thinks you can secure somebody's home network in the way that's necessary for production doesn't have children. And, you know, there are various actions you can take here. You can segment the network and all sorts of things like that. But in the end, the best thing to do is to take it to the point where you don't need to trust anything other than the application running there. You feed it keys directly from the studio is the one handing out the keys, or the VFX house is the one handing out the keys. You feed that directly to the wrapper around the application. The assets are encrypted, and frankly, if an asset is encrypted properly with AES 256, I really don't care where the hell that file goes, because it's of no use to you.
Excellent. Well, that is the time we've got, although there's a bunch more questions. We'll work to get the questions answered over in the Who app. So whoever asked them, we'll get some answers over to you. But Spencer, I just want to thank you for joining us and for your time and for presenting to everybody.
Good. And thank you for reminding me. And I really hope this has been useful introduction to what CSAP is. Excellent.
All right. That's it, everybody. Please make your way on to our next session, which is starting up right now. Thanks.
Bye.
Bye.